Okay, students, next universal set. So universal set is nothing but all sets which are in one set is called as universal set. It is denoted by rectangle. So in the next class you are going to you can understand very easily in pictures or in figures. Next one is subset. What is subset? Subset is nothing but if we have two sets. If A and B are two sets, then if all elements of set A are in set B, so whatever the elements which are in set A, the same elements which are in set B, then we can say that set A is subset of set B. Okay, so mathematically we can represent like this: A subset are equal to B. Okay, right. Two more important bits here we can write here. Right. Null set is or empty set is a subset of every set. So empty set is a subset of every set. And next, every set is a subset of itself. Okay. Every set is a subset of itself. For example, here once you observe it, for example, we take n is equal to natural numbers 1, 2, 3, 4, 5. Okay. And take one more natural numbers, that is 1, 2, 3, 4, 5. So what happened? In n, you have 1, 2, 3, 4, 5. In this set also 1, 2, 3, 4, 5. So can we write like this? N is subset or equal to n? So every set is a subset of itself. In the same way, null set. So null set is nothing but this one. And let us take this is null set is divided by 5. And let us consider set A 1, 2. So what happens? Empty set is a subset of every set. So just you have to understand that null set or empty set is a subset of every set, and every set is a subset of itself. Okay, keep that in your mind. So in the next class, I mean while solving the questions, you will get you can understand very clearly. Right? Do these questions here. He given A set A is equal to 1, 2, 3, 4, 5, 1, 2, 3, 4 elements, and set B is equal to 2, 4, and set C is equal to 1, 2, 3, 4, 7, and set F is equal to empty. Fill in the blanks with subset. This is called a subset and it is not a subset. So we have to fill with subset or not a subset. So here some questions are given in the first in this first one, A dash B. Now observe the elements of set A, elements of set B, elements of set C, and elements of set F, and we have to fill these blanks with that symbol, subset or not subset. Now observe this A and B, set A and B. A subset to B. In set A we have 1, 2, 3, 4 elements, and in set B we have 2, 4 elements. So what I said, subset means the elements. For example, you are asking A subset to B. So what does it mean? Elements of A must be available in set B. Then only we can say that A is subset to B. If you observe here, 1, 2, 3, 4 are the elements of set A, but which are not available in set B. Therefore, we can say that A is not a subset to B. Now observe this C subset to A. Now C elements are 1, 2, 3, 4, 7, and A elements are 1, 2, 3, 4. Here C elements are more. 7 is there. 7 is available in C, but that 7 is not available in A. Therefore, we can say that it is also not a subset. Next, observe second one. Now, third one. B subset to A. B elements. What are the B elements? 2 and 4. And A elements 1, 2, 3, 4. Yes. All the elements of B are available in A. Then we can say that B is a subset of A. Next, observe fourth question. A subset to C. What are the elements of A? 1, 2, 3, 4. And elements of C? 1, 2, 3, 4, 7. Yes. All the elements of A are available in set A. Then we can say that A subset to C. In the same way, next fifth question. B subset to C. B elements are 2, 4. And C elements are 1, 2, 3, 4. 1, 2, 3, 4, 7. Yes. All the elements of B are available in C and a little bit more. So we can say that B is a subset to C. Next, phi is subset to B. Just now before this class or before this, what I have given two statements. What are they? Subset, empty set or null set is a subset of every set, and every set is a subset of itself. So what is this? It is empty set only now or null set. So null set is a subset of set A, null set is a subset of set B, null set is a subset of set C also. So here null set is a subset of set B. That is the answer. Next, second question in the do this. State which of the following statements are true. First one, empty set is equal to 5. Yes, it is true. Next, 5 is equal to 0. This is false. Next, 0 is equal to set 0. This is also false. Let's try these questions. First one, A is equal to set of all quadrilaterals and B is equal to square, rectangle, trapezium, rhombus. So these are the elements of set B, and elements of set A are set of all quadrilaterals. State whether A is subset to B or B subset to A. Justify your answer. First of all, we have to write the elements of A. What are the elements of A? Quadrilateral, set of quadrilaterals. So before writing the set of quadrilaterals of set A, what is meant by quadrilateral? What is meant by quadrilateral? Tell me what is meant by quadrilateral. Quadrilateral is nothing but a closed figure which have 4 sides and 4 angles, and sum of angles is equal to 360 degrees. For example, square, next rectangle, next rhombus, next parallelogram, trapezium, and kite. So all these are quadrilaterals. What are the quadrilaterals? Square, rectangle, rhombus, parallelogram, trapezium, kite. Okay. So these are the elements of set A. And what are the elements of set B? It is given. Square, rectangle, trapezium, and rhombus. Now observe the elements of both the sets. In set A we have square, rectangle, rhombus, parallelogram, trapezium, and kite. In set B we have square, rectangle, trapezium, and rhombus. Now tell me which one is, which set is subset to, which is subset to. Therefore we can say that B is subset to A. Why? Because the elements of set B are available set A. Therefore we can say that B is subset to A. That is your answer. Okay, next second question. If A is equal to set A is equal to A, B, C, D are the elements, write all the subset of set A. Write all the subset of set A. Now we have to write the subset of set A. So what are the elements of A? A, B, C, D. These are the elements of A. Subsets of set A are, first one, you write the singleton set, set A. Second one, set B, single elements. Next, set C. Next, fourth one, it is set D. All the single elements are completed now. Now let us take two elements. That is fifth one. So we can write set A comma B. Next, sixth one, set A comma C. Next, seventh one, we can write A comma D. And eighth one, it is B comma C. Ninth one, B comma D, set B comma D. 10th one, C comma D. And 11th one. Now all the two elements are completed now. A comma AB, we got AB, AC, AD, next BC, BD, CD. Okay, next three elements. Now take three elements. What are they? A comma B comma C. Next 12th one is A comma B comma D. Next 13th one, and 15th one is, now take the four elements. What are they? A, B, C, D. And the last one, what I said, 2 points I have given. Empty set is a subset of itself. So this is an empty set. Empty set is a subset of every set, and every set is a subset of itself. A, B, C, D is set A only. So A is a subset to A only. So these are the subsets of set A. A is equal to 1, 2, 3, 4. Oh, sorry, A is equal to A, B, C, D. Four elements are there. We get 16 subsets. How many? 16 subsets. Okay, third question. P is a set of factors of 5. Q is a set of factors of 25. And R is a set of factors of 125. Which of the following is false, and explain. So here he given some options. P subset to Q, and Q subset to R subset to P, and P subset to R. So four options are given. So first we have to write the elements of set P. So what is set P? P is a set of all factors of 5. What are the factors of 5? 1 and 5 only. In the same way, Q is the set of factors of 25. So what are the factors of 25? 1 25 is 5 5 is and 25 1s are. So these are the factors of 25. Next, R. R elements are nothing but 125. Factors of 125. 1, 5, 25 and 125. So these are the factors of 125. Now, what are the elements of P? 1, 5, Q 1, 5, 25, R 1, 5, 25, 125. Now observe the first option. What is the first option? P subset to Q. P subset to Q? Yes, it is true. Next, B. Q subset to R. Q subset to R. Yes, it is also true. Next, R is subset to P. Observe it. R is subset to P. R elements 1, 5, 25, 125 and P elements are 1, 5. So all the elements of R not available in P. Therefore, no, it is false. So R is not a subset of P. Next, D1. What is D? P subset to R. P elements are 1, 5 and R elements are 1, 5, 25, 125. Yes, it is true. So R is not a subset of P. So this is the false one. Why it is false? Because the elements of R are not available in set P. That's why it is not a subset. Next, fourth question. A is a set of prime numbers less than 10 and B is a set of odd numbers less than 10 and C is a set of even numbers less than 10. Which of the following statements are true? So here he given some questions. So first of all, we have to write the elements of set A. What are the elements of set A? Prime numbers less than 10. So what are the prime numbers less than 10? 2, 3, 5, 7. These are the prime numbers less than 10. And set B elements. What are the set B elements? Odd numbers less than 10. What are the odd numbers? 1, 3, 5, 7, 9. And next to C. What are the elements of C? Even numbers less than 10. So what are the even numbers? 2, 4, 6, 8. So these are the elements of set A, set B and set C. Now observe the first one. A subset to B. A subset to B or not? 2, 3, 5, 7. 2, 3, 5, 7. But 2 is not there. Therefore, this is false. A is subset to B. False. Second one. B is subset to A. What are the elements of B? 1, 3, 5, 7, 9. 2, 3, 5, 7. This is also false. Next, third one, A subset to C. A elements of 2, 3, 5, 7 and C elements of 2, 4, 6, 8. So 3 and 5 is not there. So it is also false. Next, fourth one, C subset to A. C subset to A, 2, 4, 6, 8, 2, 3, 5, 7. So it is also false. Next, fifth one, B subset to C. B elements 1, 3, 5, 7, 9 and C elements 2, 4, 6, 8. So it is also false. It is not a subset. Then sixth one, phi is subset to A. It is true. Why it is true? Because every empty set is a subset of every set. This one only true. Phi is a subset of set A. So next topic is Venn diagrams. So whatever we have done, that one we have to express in diagrams. Okay, in Venn diagrams, we use specially one rectangle. So already I have said that a rectangle is nothing but it is called as universal set. So what is this? It is called as universal set. And universal set is denoted by U or mu. U or mu. So U or mu, that is called as universal set. And for example, if A and B are two sets, A and B are two sets, then how to represent that sets in this Venn diagram? It's very simple. So we'll take one rectangle. So in that we can take one set as circle. So this is called as set A, and one more set we may take like this, set B. Okay. So we represent universal set by using a rectangle and sets by using circles. Okay. Now by using this Venn diagram, now we are going to perform some operations. So let us see the operations. Okay, next basic operations on sets. So in that first one, union of sets. So what is meant by union of set? The union of set A and set B is a set which consists of all elements of set A on set B, and it is denoted by U. So it is denoted by U, and symbolical or mathematically we can write A set A union set B is equal to X such that X belongs to A or X belongs to B. Okay. So this is the symbolical representation of union of sets. So let us take one example. What is one example? We can take one example. For example, set A is equal to 1, 2, 3 and set B is equal to 1, 5, 7. Okay. Now I want to write this this operation, that is union of this A union B is nothing but, so we have to write the elements of set A. What are the elements of set A? 1, 2, 3 and this U you have to write here. Next, set B elements. What are the set B elements? 1, 5, 7. Okay. So A union B is equal to, now write all the elements of set A or set B. So let us write in the ascending order. 1, 2, 1 is twice, you write only once, 2, 3 and next 5, 7. So this is the representation of A union B. Okay. Now if I want to represent this in Venn diagram, so how to represent this in Venn diagram? So what we have to write? We have to draw one rectangle. First of all, we have to draw one rectangle. That rectangle is nothing but mu, universal set RU. So it is represented by mu RU. Next, set A. This is set A and this is set B. Circle, first circle is set A and second circle is set B. Now observe the elements of set A and elements of set B. So in set A 1 is there and set B also 1 is there. So that one, that element we have to write in the common area. So this is a common area for both the circles. Yes or no? Observe this one, this part. So this part is a common area for both the circles. So common elements you have to write in this region. Okay. Now you close this one. What are the elements of A? 1, 2, 3. So you already, this is the region of A, no? So already 1 we got here or we have written here. Then 2 and 3 we have to write it. Okay. Next. 1 already we have written for set B. Remaining elements are 5 and 7. Then we have to shade this total region. So this is the representation of A union B. Okay. So this is the representation of A union B in Venn diagram. Okay. Right. Next, intersection of sets. Intersection of set A and set B is a set which consists of common elements from both set A and set B, and it is denoted by inverted U. Inverted U. Symbolically, we can write A intersection B is equal to X such that X belongs to A and X belongs to B. Whereas A union B, X such that X belongs to A or X belongs to B. Then a slight difference and or. Okay? Right. A intersection B is equal to X such that X belongs to A and X belongs to B. So let us take one example. For example, we can take if capital A, set A is equal to 1, 5, 8 and capital B is equal to 2, 4, 5, 6, 7. Okay. Now we have to write, let us perform the operation, that is intersection. So what are the elements of A? 1, 5, 8. Intersection. Elements of B? 2, 4, 5, 6, 7. So what are the common elements? 5 and 5. Only 5 is the common element. So you write only the common elements. So this is the intersection. Okay. So what is the intersection B? 5. Now if we represent in Venn diagram. So how to represent Venn diagram? First of all, we have to draw one rectangle. What is that rectangle called? It is called as universal set, denoted by U or mu. So draw one set, draw one circle and name it as set A. Draw another circle and name it as B. Okay. Now we have to write the common elements. So this is a common region for both set A and set B. No? So this is a common region where we have to write the common elements. So in both the sets we have only common element, that is 5. So this is nothing but intersection. A intersection. And remaining elements we can write here. So what are the elements of A? 1, 5, 8. Already 5 we have written here. And remaining 1 and 8 we have to write here. And set B elements are 2, 4, 6 and 7. So this is a representation of A intersection B in by using Venn diagram. Okay. Do these questions. So whatever the operations we have performed, now we are going to apply here. Do this. Let A is equal to, set A is equal to, the elements are 2, 4, 6, 8, 10, 12 and set B is equal to, the elements are 3, 6, 9, 12, 15. Find A union B and A intersection B. First of all, we have to write given set A is equal to 2, 4, 6, 8, 10, 12 and set B is equal to 3, 6, 9, 12 and 15. Write A union B. Let us perform the operation A union B, that is set A. What are the elements of A? 2, 4, 6, 8, 10, 12. Close that. Next, write union here and open the bracket and add the elements of set B. What are the elements of set B? 3, 6, 9, 12 and 15. So according to our definition, we have to write all the elements from set A or set B. Okay. So let us write in the ascending order. First one we have to write 2, next to 3, next to 4, 6 is repeated in this and in both the sets are there. No problem, you write as single or write as once. Next 8, next 9, 10, 12 is repeated, write only once, and the last one is 15. So this is the A union B. Okay, A union B is equal to 2, 3, 4, 6, 8, 9, 10, 12. Next, we have to perform, or we have to do the operation of A intersection B. So what are the elements of set A? 2, 4, 6, 8, 10, 12. Close it and write the intersection symbol. Open the bracket and write the elements of set B: 3, 6, 9, 12, and 15. Close it. Now, in both the sets, you check the common elements. What are the common elements? Here it is 6. In this also you have 6. Here it is 12. So in this set also you have 12. So how many common elements are there? Only 2. What are they? One is 6 and one more is 12. So this is the A intersection B.